Today's lesson is on multiple transformation and asking the question, does the order in which we do the transformations matter to the end result? And there are only 6 different combinations of 2 different transformations one can do. You can do 2 translations, 2 rotations, a translation and a reflection, a translation and a rotation, a reflection and a rotation, and 2 reflections. This lesson is going to go over the first 5. Reflection and reflection we will go over in a different lesson. So today we're going to go over, the first thing we're going to do is go over translation. So in this example, there are 2 different translations. Go 3 to the left and 2 down, and 1 to the right and 2 down. And so in the first example, on the left, we're going to do 3 left and 2 down first. So I go 3 to the left and 2 down, mark my point, 3 to the left and 2 down, mark my point, 3 to the left and 2 down, mark my point, and there's my new triangle. Get rid of all that other stuff. And now we're going to do the second translation. 1 to the right and 2 down, 1 to the right and 1 to the right and 2 down, mark my point, 1 to the right and 2 down, mark my point, draw my triangle, get rid of all the intermediate steps, and there is my final triangle. Now on the one on the right, we're going to do in a different order. So we're going to start by going 1 right and 2 down, mark my point, 1 right and 2 down, mark my point, 1 right and 2 down, mark my point, mark my triangle, get rid of all that other stuff. Now we're going to go 3 left and 2 down, 3 left and 2 down, mark my point, 3 left and 2 down, mark my point, 3 left and 2 down, mark my point, draw my triangle, get rid of all the intermediate steps. And when I look at those 2 triangles, the answer is they are the same. They're in the same place. And the reason for that is that these things are additive. If I'm supposed to go 2 down in the first step and 2 down in the second step, then I went 4 down in total. If I'm supposed to go 3 left in the first step and 1 right in the second step, then I end up going 2 left. And if I go 1 right and then 3 left, I still end up at 2 left. So translations are additive. So does the order of the transformations matter? And the answer is no, it does not for translations. It does not matter. Now let's look at the next one, which is a rotation, 2 different rotations. And so in this example, we have 2 different rotations, a 90-degree clockwise and a 180-degree clockwise. And we're going to do them in different orders and see if the answer changes. So for this one, we will rotate 90 degrees clockwise, mark our points, draw a triangle, move it back. Now we're going to take that new triangle and rotate it 180 degrees, mark our points, draw our triangle back, get rid of the intermediate step, and there we can see is the result of a 90-degree clockwise rotation followed by a 180-degree rotation. On the example on the right, we're going to start with a 180-degree rotation, mark our points, pull the paper back. Now take that second triangle and rotate it 90 degrees clockwise, mark our points, put our triangle back, get rid of the intermediate steps, and you can see that indeed those are exactly the same. So again, for rotations, they're also additive. If in the first example I'm going 1/4 turn and then a half turn, I've gone 3/4 turn total. On the example on the right, if I go a half turn followed by a 1/4 turn, well, that adds up to 3/4 of a turn total. So I have, in both cases, gone 3/4 of a turn. And so to answer our question, does order matter for rotations, for 2 different rotations? And the answer is no, it doesn't. Now let's try a third example of translation reflection. Before we do anything else, we should talk about this terminology because you probably haven't seen it before. This is simply suggesting, this says translate 3, 5, so translate 3 to the left because it's negative, and then up 5 because it's positive, and then reflect over the y-axis and do that to triangle ABC. This is the opposite. This is saying first reflect over my y-axis, then I want you to translate 3 to the left and 5 up for triangle ABC. Okay, so now that we have those, the question is, will the order matter? So first we're going to go 3 to the left and 5 up, mark our point, 3 to the left and 5 up, mark our point, 3 to the left and 5 up, mark our point, draw in that triangle, get rid of the intermediate step so I can see my triangle. And now I want to reflect over the y-axis. So I go 3 to my line of reflection, so I keep going 3 more to the left, mark that point. For B, I go 2 to the left, so continue 2 to the left and mark that point. And for C, I'm actually right on the line of reflection, so it stays on the line of reflection, so that's be C prime. Put in that new triangle, get rid of all the intermediate steps, and there is the triangle that has first been translated, then been reflected. Now on the right, we're first going to reflect it, so across the y-axis. So 6 to the left, 6 more, mark that point. 5 to the left, 5 more, mark that point. 3 to the left, 3 more, mark that point. Put in that triangle, get rid of my intermediate steps, and you can see there is my first transformed triangle. My second transformation is a translation. 3 to the left and 5 up, 3 to the left and mark the point, 3 to the left and 5 up, mark the point, 3 to the left and 5 up, mark the point, draw my triangle, get rid of all the intermediate steps. And in this example, we can see that the triangles are actually quite different. The one on the right is 6 units to the left compared to the one on the left. So, does the order matter for a translation reflection? And the answer is yes, it does. If we're going to move something around and reflect it, the order in which we do those two steps matters for the end result. Next, we're going to look at a translation and a rotation. Does order matter? So this first one is asking me to first translate 6 down, then rotate 90 degree counterclockwise. And the other example is asking for first to do the rotation, then to translate. So first we have to go 6 down, mark my point, 6 down, mark my point, 6 down, mark my point, put in my triangle, get rid of all those intermediate steps, and there is my triangle 6 down. Now I need to rotate 90 degrees counterclockwise, so I'll rotate that whole paper around, draw in my new points, J double prime, K double prime, and P double prime, put in my triangle, put the paper back, get rid of that intermediate step, and there is the example of translating 6 down and then rotating 90 degrees counterclockwise. Now for the example on the right, we're going to first rotate 90. After we've rotated 90 degrees counterclockwise, then we're going to put in our points, J on my triangle, put it back. Now that I've done that, I need to translate 6 down. To do that, I need to extend my graph paper. 6 down, mark my point, 6 down, mark my point, 6 down, mark my point, draw in my triangle, get rid of all intermediate steps, and we can see that the answer is that these are very different. That if we translate then rotate, we come up with very different result than if we rotate then translate. So does the order matter? The answer is yes, it does. If we translate and then rotate, the order does matter. Next, we're going to look at a reflection and a rotation. Does the order matter for those? So again, our terminology, we have this says reflect the x-axis. Then once I'm done with that, then rotate around the origin 90 degrees for triangle ABC. And this one is saying first rotate around the origin 90 degrees. Then when I'm completed with that, take that new triangle and reflect it over the x-axis for triangle ABC. Okay, so the first step I have to do is reflect over the x-axis. So let's mark 8 down, 8 more, mark our point. 7 down, 7 more, mark our point. 3 down, 3 more, mark our point. Draw on our triangle, get rid of all those intermediate steps, and there we go. Now that I've done that, I'm going to rotate 90 degrees clockwise. Thusly, mark our new points. That will be A double prime, which is at -8, -1, B double prime, which is at -7, -4, and C double prime, which is at -3, -1. I'll write those points down, turn my paper back around, so now I can put those points in, put in A at -8, -1, B at -7, -4, C at -3, -1, put in my triangle, get rid of all the intermediate steps, and there is the example of taking that original triangle, translating it, one more time, reflecting over the x-axis, and then rotating it 90 degrees around the origin. Now the example on the right, first we're going to rotate 90 degrees around the origin, put in our points. So A prime is 8, -1, B prime is 7, -4, C prime is 3, -1. Let's write those points down so we can rotate our paper back, put in those new points, and draw our triangle. And so now I have rotated, but I still need to reflect across the x-axis. So A is 8 points away, go 8 more, write down my points, it's -8, -1. B is 7 to the left, so go 7 more, mark down my point. C is 3 to the left, 3 more, mark down my point, draw my triangle, get rid of all the intermediate steps. And here you can see that indeed these two triangles are the same. They go to the exact same place. So the question is, does order matter if I'm going to be doing reflections and rotations? And the answer is no, it does not matter. The only time order matters is if I'm going to be moving something, sliding it through a translation, and then reflecting it and rotating it. It matters then that it would be a different order if I rotate or reflect it first and then move it.